All right, we are going to get started. Hello, everyone, virtually and in person. I appreciate everyone taking the time for making it today on this very snowy, blistery day, but I appreciate it. I am going to get us started, and then I'll be handing it off to our presenters for the day. So give me a moment. I'm going to share my screen. Oh, it's already sharing my screen. Okay, virtual folks, are you seeing my presentation? Or are you seeing my presentation notes? Oh, yeah, that's what I was afraid of. Okay. Sorry. I don't like, it doesn't recognize this as a different screen. Okay, so I'm just going to, you're all, virtual people are just going to see my notes. I hope that's okay. Okay, great. All right, thank you and welcome everyone to Energy Efficiency Analysis Performance Optimization with RETScreen. My name is Miranda Wright. I'm the Education and Engagement Manager here at Illinois Green. Thank you again for all of you who've fought the snow and for all of you who are able to join us virtually. You are in a Zoom meeting, so I do ask that virtual participants just keep yourselves muted throughout the presentation portion. There will be time to discuss and have open dialogue, so feel free to unmute yourselves then. For those of you who are unfamiliar, Illinois Green Alliance is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. Our 5-year strategic plan pushes the green building industry to meet or get on the path to net zero. We achieve this work through educational events, such as panels and building tours, by engaging communities and partnering with organizations across Illinois, and by advocating for new policies and legislation. I also want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, USGBC, and Sloan. And with that, I'm going to go ahead and pass it over to our Baumann Consulting team to introduce themselves and get you all started. Okay, there you go.
Good afternoon, everyone. Thanks, Miranda, for the introduction. So my name is Hardik Miani, and I'm currently working as Energy and Decarbonization Project Manager with Baumann Consulting. So our firm is currently based in Chicago, Washington, D.C., and Frankfurt office in Germany, where we work on a lot of sustainability, energy efficiency, commissioning, and building performance analytics simulation softwares for our projects. So along with me, I have Hiten Chajet from Washington, D.C. office, who will be also providing us with a training for the RETScreen software today. So before we get started, if we can please introduce ourselves and also mention like how many years of experience do you have in the energy efficiency domain? It will help me to cater the presentation for today.
My name is Grace. I currently work here, and I'm doing a lot of like mechanical system decarbonization work. I've only been in the industry for 5 months, so this is still very new to me. I'm excited to learn about more tools that I can use.
Nice.
Both in that field and beyond.
Okay. Yeah.
I'm Cece. I do independent research at my university. My background is in computer science. I've been interested / kind of doing adjacent research for the last 3 months. So
nice.
Very new.
Okay. Yep.
My name is Kyle Bondrek. I'm an electrical engineer with Smith Group. I have about 8 years experience in electrical design, but not much experience with energy efficiency.
Nice. Okay. People on Zoom call, Matt, if you could please introduce. Can people on Zoom call hear me? Okay, I think the audio is mute, but I think not to further delay for today, we will get started with the training for the RETScreen. So first I will start with the overview about RETScreen, what RETScreen software is and where it is being used in the industry. Okay, I think the people who are seeing my screen should be able to see that. Okay, so the agenda for today, we will be learning about the RETScreen overview, what the software is about, what are the application of the software, where we can use this software, the limitations. We will be going through a few case studies and also answering any question answers that we have for this software training. Starting with the overview. So RETScreen. Oh, okay. Perfect. Yeah, perfect. Thanks. Yeah, RETScreen, as the name suggests, it is known as Renewable Energy Technology Screening. This is a software that is developed by the Canadian government, similar to like in the United States, we have Department of Energy. In Canada, there is Natural Resources Canada who has developed the software. So this is a clean energy management software that is widely used in Canada and across the globe for energy efficiency, renewable energy, or cogeneration feasibility analysis for any of your energy performance analysis project. So this software helps to quickly gauge facilities energy performance, like how it is currently performing against another property. If you have any project where you want to do a feasibility analysis, whether this is a good solution for that project or not, or if you want to do a cost analysis, saving analysis, if you have a project where you want to do a quick estimate, like what is a GHG emission reduction. So everything is possible with this software. Again, it can also be used for determining what is energy production, the savings potential across any place in the globe. It is also used to verify the performance of the implemented projects. Like suppose if you are working on any retro commissioning or commissioning based projects, this is also a place where you can verify, do measurement and verification with the utility bill analysis and confirm if what is a reduction in the energy savings. And again, if you have a wide portfolio of projects, right? If you have a client that has multiple buildings and they want to do a portfolio level analysis, how is each building performing at their portfolio? That is also a capability that RETScreen provides through its simulation. So the RETScreen is currently available in 38 languages across the globe. That covers almost 2/3 of the world population. So be it in Africa, in India, in Russia, any place, people are using RETScreen software. So these are the developers and partners who are associated with RETScreen, who have helped them to build the software. As I mentioned, the Natural Resources Canada is very similar to the United States Department of Energy out there in Canada, who has partnered with RETScreen to develop this. Other partners includes the Renewable Energy and Energy Efficiency Partnership, the Independent Energy System Operators, United Nations Environment Program, and NASA. So all these firms are directly or indirectly helping RETScreen. Like for any analysis that we do, we need the ambient temperature and the weather data, right? So that is a place where they fetch the information from the NASA satellite for grabbing all those information. So we need information about the groundwater as well. So that is a place where they collaborate with all the developers and partners for doing all the simulation work. Application of the software. So at a high level, RETScreen is widely used in the industry for multiple aspects, starting with virtual energy analyzer. Like suppose if you're going on a site visit, the client needs a very high level estimate, like what is energy saving potential for that particular property, right? So that is a place I will use virtual energy analyzer. So that is the software itself has an archetype, which means sort of a dummy model. Like suppose if I'm doing an audit for a warehouse, I will use a dummy model and see like what is the energy saving potential with the lighting retrofit. And that is something that I can potentially do without gathering too much of information about the property. Benchmarking analysis, as everyone knows, benchmarking is specifically used to compare how is my building performing as compared to other building in the similar location of similar size, right? So right now everyone knows about Energy Star Portfolio Manager, which is widely used in the industry in United States and Canada. But what if my project is currently located in Africa, right? There is no benchmarking for that. So that is a place RETScreen comes in place, right? So RETScreen has a very good database across the globe. Like suppose be it any project in any part of the world, they have a benchmarking. Like if I create a virtual model about my software, I will be able to analyze how my building is performing as compared to another property for the same location. Feasibility analysis, again, it is used for clean energy soft projects. If I want to do a feasibility analysis, whether electrification is possible or not, right? If I upgrade my windows from double pane to triple pane windows, whether it is feasible or not. So feasibility is not only from technical perspective, it is also the financial feasibility, the cost analysis, GHG emissions, everything. Performance analysis, again, this is something used for retro commissioning and monitoring based commissioning for energy performance contracting, where you have the utility bills for the client right now. And after implementing the measures, you will see a reduction. So what is that actual reduction is something you can determine using RETScreen. And portfolio analysis that you can use for property for any client that has multiple buildings across their portfolio. Again, these are the applications that where the RETScreen is currently used. It is used in power plants, the power heating cooling industry, power storage and off-grid. Like if you have any battery storage, thermal storage, and you want to do a feasibility analysis, you can use that. Industrial and agricultural industry, that is a place where if you install, like if you fix or upgrade a motor, right? So that is a place where you can do a feasibility analysis, how much is the savings potential. Commercial institutional, this is very similar to the energy audit that we do. Residential, again, similar to that. Like if I install a solar PV panel on my roof, like what is the energy generation possibility? What is the financial associated with that? And that is the analysis that we can do. And transportation is a place where you can estimate what is the GHG emissions from the different modes of transportation. So as any software, RETScreen has few limitations that it takes into consideration while doing the analysis. First, it is a degree day simulation model. Second, it does not include latent load in the calculations. So there are two types of loads, latent and sensible. So sensible is something like if there is a change of temperature. If I ask this space temperature needs to change from 72 to 75, that is a sensible load, right? But latent load is something where there is a change of phase. If I am transitioning from ice to water or water to steam, that is a place where I'm changing the phase of a particular material, right? That change of phase is not taken into consideration while doing RETScreen analysis. Simultaneous heating cooling is not covered in RETScreen, right? If there is a place where there is a cooling that is coming into this space and there is a electric heater that is on, so RETScreen can't do a comparison of like there is a simultaneous heating cooling happening in the space. Occupant sensible and latent heat gains are not taken into consideration. It can only estimate what is the heat being rejected by the lamps, or if there is electrical equipment, or from the sensible loads. But it cannot take, like if there are, it depending upon the occupancy in the building, it cannot determine what is the sensible and latent load rejected by the occupants in the space. It cannot specify when during the day building is occupied. So over here, we will be learning, like we can certainly specify the operating hours. Like suppose if I say this space is occupied for 12 hours per day, right? RETScreen will consider that 12 hours, but it cannot say it is operating from 9 a.m. to 9 p.m. right? So it will take into consideration the total hours, but not the actual time duration when it is operating. Power factor correction is not taken into consideration while doing the analysis. And last, it does not calculate the reduction in the peak demand. the major focus using this software is reduction in the energy and not on the peak demand. So now we will get started with the software itself, how to use the software, what are the features that are available, and I will be diving into each and every different example so that it will help you guys to get trained for that. But before we get started, these are few cell color coding that we need to remember while working on RETScreen software. So any cell that is in white color is a place that is a model input that is calculated by the model, that is done by the RETScreen software. Yellow is a user input and it is required to run the model. Until and unless we don't fill in the cell in yellow, we won't be able to do the calculation. The one in blue, it is required to run the model and there are online databases available. If I come across a situation where I need to input the efficiency for a particular boiler, but I don't know what the efficiency is. So there is a database that is available that I can take as a reference, and that can be used as a analysis for my software. Gray is the user input for that, which is for only for reference only, and it is not required to run the model. So you can skip those part while working on the model. So whenever we approach any energy efficiency project, the first thing that we need to understand, what are the fuel sources in the building, right? Is it an all electric building? Do they have natural gas that they are using for heating? Do they have any source of diesel or oil that they are using for any sort of generation in this space? So that is the first thing that we will be using whenever we are working on any energy efficiency project, right? Once I understand the fuel sources, next I need to understand what are the major equipments in the building, right? Chillers, boilers, furnace, domestic hot water, absorption chillers, heat pumps. Those are the major equipment that are being used in the building, right? Next, I will be developing what are the end users. I have this equipment, what area it is serving, right? So we will be having lighting, we have the ventilation, we have the pumps, fans, motors, electrical equipment. So those are the things that we will be. So once we develop the baseline case for the model, so that is like, suppose if I'm doing an energy audit for this space. So this is something we will consider as an example throughout our project. If I am an energy auditor, right, I will be coming into this space. I will be looking what are the baseline system in this building, right? So I will count the number of lamps. I know there are few electrical equipments, right? I will understand what are the thermal properties of this building construction, right? I will be looking into what are the thermostat set points, what are the system that is providing heating and cooling in this space. So those are my baseline conditions, right? Now as an energy auditor, I need to identify how can I reduce energy consumption for this space, right? So if this is a fluorescent lamp, one opportunity is I can do a lighting upgrade, right? If there is a thermostat that is having a very weird set points, that is a control upgrade, right? If I know this wall insulation is not good, I can probably do a feasibility analysis, how much worth it is to add an extra layer of insulation. If there is any air leakage that I identify through doors or windows, that is the place where we can do a clocking. We can estimate the energy savings associated with that. If I am using any electrical appliances that are not Energy Star rated, right, that is another place where I can recommend to my client, like install Energy Star rated appliances. So that is a place where we start with the minimizing the usage. Right? Once we understand the base load, our first goal is to minimize the usage. Then we maximize the efficiency. That is a place where we upgrade the equipment, right? If you come across, there is a boiler that is being used for heating, but everyone knows now that heat pump is much more efficient as compared to a conventional boiler system, gas fired boiler. So that is a place I'm maximizing the efficiency by replacing the equipment. And after that, anything that is remaining, that is a place where I can potentially install a renewable technology to make my entire project net zero. So the meaning of net zero energy is the amount of energy that is being consumed by a particular space, equivalent amount of that of energy you are generating on site, right? So be it electricity, if I know if I'm using 100,000 kilowatt hour of energy, electricity annually, I will be generating an equivalent amount of electricity either on site or it could be I can buy renewable energy credits as well. So there are multiple ways we could potentially make our project net zero. So this will be the approach that we will be using throughout our software training. Any questions so far? Okay, hearing none. So has everyone got an opportunity to install the software? Any difficulties faced? Anyone online? Oh, sorry. Yeah. Okay. Okay, so to get started, so first I will be providing an overview about what are the capabilities of the RETScreen software. So if you open the software, this is how the dashboard will be looking like. So you get started with selecting a blank project. Since this project is developed by people in Canada, it is all the units of measurement is in metric system, right? So first thing we need to always remember whenever we are working on RETScreen software to ensure we are selecting proper metric system, right? One easy way to update all the settings is you go into the settings, you can select the currency, or first you can select your language, whichever language you are comfortable working with. I select English out here. The currency, if you have any project based in United States, you can select USD. By default, it will be considering Canadian dollars. The dollar sign refers to the Canadian dollars. But if you have a project in USD or any part of the globe, you can select your currency accordingly. Units of measurement, by default, it will be metric. If you have projects in United States, I would suggest selecting imperial out there. Next is there is also an option for you to select by default like a facility location as well. Like if you know like most of your projects will be based in Chicago, you can select a software default where you can get started. And next is the exchange rate. Ideally, this will be automatically updated in your cost database. But if you have a separate exchange rate that you want to use for any other projects outside USA, this is a place where you can use it as a adjustment factor. And yeah, second over here out here in natural gas, by default it considers cubic meter. Most of our natural gas bills in United States is based in therms, so you can set that as a default. And yeah, so these are few default values that I would highly recommend updating in your software, so that each time you open the software, you don't need to make changes to your model. Okay, so going back to the home screen. So this is how the dashboard will be looking like. So as we discussed, there are multiple features in benchmarking. We need to define the location and the facility type. In the feasibility analysis, we could do what are the energy saving potential. We can do cost analysis, emission analysis, financial analysis, risk analysis. And in the performance tracker, you can do data analytics and reporting aspect of that. Anything related to the portfolio, if you're working on portfolio based, this is a place where you can get started with. This is a place where you can see where RETScreen is widely used in the industry. One very good feature about RETScreen, like suppose if you are using the software after this training, right? You have multiple questions. RETScreen has a very good e-learning database. So all the training that I will be giving today, it is available on YouTube channel. So anything related to energy efficiency work, or if you're working on solar PV or wind turbines or CHP analysis, any feasibility analysis that you want to do, all the analysis, all the training material is available on YouTube that you can take it as a reference after this training. And yeah, these are a few other stuff. But to get started, so has everyone received this worksheet, RETScreen training worksheet? So this is a worksheet that we will be keeping as a reference for our training today. So for our training, so I will be teaching about the benchmarking, how to do benchmarking in RETScreen. We will be learning about how to do lighting up retrofit. We will be learning about HVAC, like if there is any control measures. Yeah.
Sorry.
Yes. So if you select 180 guest and the password is North LaSalle.
Trying to get the
Yeah, no worries.
worksheet.
Yeah. Yeah, let me know once you have, then I can get started. $180 guest. LaSalle. Okay, are we ready? Perfect. Okay. So we will be learning about benchmarking, lighting retrofit. We will be learning about HVAC system. If there is any control upgrade that you are planning to do, what is the savings associated with that? We will be learning about installing VFDs and learning about the financial analysis using that. And then we will be learning about the building envelope aspect of that. And later on, Hiten will be training us about 2 case studies that I would like you guys to do on your own. And at the end of the training, we will be discussing what are the solutions and how to set up in RETScreen. Okay, so to get started, so first example for us is to benchmark a property. So we are responsible for conducting a walkthrough energy audit at a commercial building located in Chicago. Okay, so that's the first line. So I will be, so 2 things that I got to know from this. One, it is a commercial building. Second, it is based in Chicago. So what I will do is I will go into RETScreen software. I will select all. I mean, it depends, since I will be doing multiple training, I mean today. So I will select all. But if you are working specifically on benchmarking, you can select only benchmarking. If you're working only on feasibility, you can select feasibility. But all gives, like, opens all the tabs for you. So starting with the location, we know it is based in Chicago. So we will select this globe icon out here. And that is a place where I will select Chicago. I will type in Chicago and select search. So what, sorry, one second. So now based on my location, RETScreen has recommended multiple weather stations that are close to my location, right? So it includes the Midway Airport, the Magnificent Field, the Gary, Chicago, O'Hare, Glenview. Depending upon what I want, I can select anyone. I'm assuming it is currently based in Chicago downtown, so I'm selecting the second option out here. So once you select that, select yes out here, paste data, and automatically all your weather files will be updated. So this is a place where all the weather file, it is importing all the weather files for your simulation. Let me know if I need to reduce the pace, I can adjust accordingly. So over here, the weather information that it captured was the ambient temperature, humidity, precipitation, solar radiation, atmospheric pressure, wind speed, heating and cooling degree days. So all this information will be used for doing the analysis. And this is the climate data. It is just plotting a graph, how the weather is for the city of Chicago. So now I have loaded my weather file. Next, they have asked, it is a commercial building, right? So I will go into the facility tab. So now in the facility type, we know it is a commercial building. So I will, in the drop down, I will select commercial and institutional. And it is an office building. So I will select office building. And as we mentioned, everything in yellow is required. So this is a place where you can write I mean, it won't be used for your analysis, but just while you're creating a report, that is a place where all this information will be used. If you want to write anything in gray, it is not required. It is an optional, but if you want to create a report, this is a place where you can write down the address and all the stuff. You can certainly update the image as well. You go into the select image. This is a place where you can select any property images specific for your project and change the graphics out here. Okay, so next step in the process, it is okay, the size of the facility is 10,000 square feet. So I will enter the facility size, 10,000 square feet, right? Next, last year, the building consumed 10,000 therms of natural gas and 105,000 kilowatt hour of electricity. So in RETScreen, there are two ways you can do benchmarking. That is known by level 1 and level 2. The higher the level, the more detailed information you need to provide for your analysis. So level 1 includes like a high level benchmarking. I don't have electricity and natural gas split. I know the overall kilowatt hour per square feet or EUI for the property. So that is a place where I will use level 1. But based on the information that RETScreen has provided, they have given us a split between natural gas and utility. So that is a place we will go into level 2, right? So that is a place. So I know for electricity it is 105,000, and for natural gas, again, always remember the metric system. Out here it is in cubic meter, sorry, but we need it in therms. So it is 10,000 therms, right? Okay, so now RETScreen has estimated the EUI for my property directly. So my EUI for electricity is 10.5 and for natural gas is 29.3. Overall for my building, it is 39.8. Does it make sense? Okay. Now the client has set a target, like they want to have an energy reduction for natural gas by 10% and electricity consumption, they want to reduce it by 20%. Okay. So now that is a place where I set a target. For electricity, it is 20%. And for natural gas, it is 10%. So that is a place where I can determine. So this is my base case. That is a place where how my property is currently consuming. And this is the target that the client wants to achieve, right? So how much energy do I need to reduce? That is a place where RETScreen can give us an analysis about that, right? So my proposed case will be having this energy EUI for the property. Now, suppose if I come across a property that is based in Africa, I don't have a database. I don't know how the building is currently performing, right? So what I will do is, assuming I have the EUI for that property, assuming it is 39.8, what I can do is I can go into the level 1. My base case that my building is currently performing is, sorry, what was 39.8. So what I will, my base case is 39.8. So that is how my building is currently performing. Now I don't know how my building is performing against any other properties for that location. So what I will go do is I can go into the benchmark database. So RETScreen has created a very good database for all the properties across the globe. So that is a place what I will do is I will do a reset. I will select the location where I want to compare my property against. So what I will do is I know my property is based in United States. And it is in the Midwest region, right? So I will select Midwest. Second thing that I know, my building is a commercial building, right? So the facility type for me is a commercial or institutional, right? And out here, I know it is an office building. So there are two benchmarking database that I have that I can refer. And again, depending upon my location for the property, I will select either east or west, wherever my project is located. For now, I will assume it is 213 kilowatt hour per square meter. Again, look into the matrix. It is not square feet, it is square meter, right? So it is 213. So what I will do is I will take that as a reference. Since this is asking in square feet, what I can do is I can change this to square meter for temporary. I can make this 213, that is my benchmark, and again change it back to square feet. So this gives me a good understanding. My building is currently consuming 39.8 kilowatt hour per square feet. For any other property in the same location of the same type, it is consuming 19.79. This gives me a good understanding. There is a very good energy saving potential for my property. So I can start with energy audit. Does it make sense? Any questions so far?
Change the location.
You go into the location. That is a place where you change
No,
the
sorry, not the location. What you're-
benchmarking. Oh yeah, so you go into the benchmark
Benchmark
database.
up there.
Yes. And that is a place where, depending upon the location, type of facility, so there are multiple filters. There was also a filter where you can select the age of the building as well. That could be one of the factor. Area of the building. So there are multiple factors that you can use to determine benchmarking. So now I know my building is out here. It is currently consuming, sorry, this is in, yeah. So my building is currently consuming 39.8. That is my baseline. And the target, the benchmark that I have is out here. Now client sets a goal. I want to reduce by only 20%. I don't want more than that. So that is a place where I can show to the client, like this is the energy saving potential for your property. And if they want to reduce it with the benchmarking, that is, they need to make a reduction of 50% to meet the benchmarking requirement. And if they want to go net zero, it's like a complete reduction in the savings, right? Or whatever they are consuming, it needs to be zero out there. So accordingly, you can use this graph for your reporting as well to show to the client how it is currently performing. There is also an option where you can keep a track of their emissions benchmark as well, and the cost benchmark as well. How much electricity or natural gas electricity cost, rather utility bills that they are paying against other properties. So this is all for, no, sorry, there are a few other things. Other information that they have provided now is a facility. This same facility is currently paying $1 per thumb for their natural gas bills, right? So now we know, okay, first thing we did was benchmarking. We understood the building has a very good potential for doing energy savings, right? Now, next step, I will understand what are the fuel sources. We know electricity and natural gas based on the information provided. So what I will do is I will now go developing a virtual model about this building. So I will go into the energy tab. I will select electricity and fuels. And that is a place where I can define what are my fuel sources in this building. Okay. So for me, I have a natural gas and it is per thumb. And they have provided it is $1 per thumb. So I will select that. And for electricity, I'm currently, the client is paying 14 cents per kilowatt hour. Right. Now, suppose if you come across a client who doesn't want like a marginal rate, they want a very detailed utility bill analysis. So that is a place where you select this icon, the electricity rate calculator, and you can do a very detailed analysis month by month. What is my electricity being consumed? What is my peak load? What are my fixed charges? What is the total electricity cost that they are paying? And accordingly, RETScreen will help you to estimate what is the blended cost that you can use. And again, there are multiple ways you can estimate. One is, so the first option is on a monthly basis. Second is time of the use. At what time, what is my electricity rate? Usually, if you see in the commodity market, the cost for electricity changes throughout the day. Like during afternoon, the price of electricity is more. During evening time, it is less. So that is a place, if you have the client who wants you to do a very detailed analysis, this is a place where you could potentially use. Same if there is any advanced version, depending on how detailed the client would like you to go, this is a place where you can use RETScreen. And if you have any other fuel sources apart from electricity and natural gas, this is a place where you select plus sign and you can select any other fuel sources as well for your property. In this case, since we have only electricity, natural gas, I will remove anything extra. So I'm deleting that. Good until here. Okay. Next, they ask the building thermostats are currently set for 68 for heating and 72 for cooling, and it is operating 24 hours per day. If you come in this space, you saw the thermostat set point. Heating is 68, cooling is 72, and it is operating all the time, no matter what, whether the building is occupied or not. The systems, the lights, everything will run 24/7. So I will go into the schedule. That is a place. My heating is at 68. cooling is 72, and my changeover temperature out here, they have given it is 65. The meaning of changeover temperature is what is the ambient temperature at which my system changes from heating to cooling mode or cooling to heating mode. So ideally it is in the range of 60 to 65. The way we determine, there needs to be like a detailed utility bill analysis that gets done. But for now, we will assume it is 65. By default, RETScreen gives you like your model is operating 24/7. But if you come across a property where the operating hours are different, this is a place where you can set a new schedule. You can define whatever schedule you want, whatever the occupied and unoccupied set points you have, and the number of hours it is operating on a daily basis, right? You can use this schedule as well. For now, we won't be using that. So this is the first part of the example that we have done. So we learned about how to set up a facility type. We learned about how to set up a location. We learned about the benchmarking, level 1 and level 2, right? How to set a target for the facility. What are the fuel sources and how to do the rate analysis, and how to set up set points for the building. Any questions so far? Yes.
Is the only difference between
Yes. Yeah. For level 1, it is combined for the entire building. It doesn't matter if it is electricity or natural gas. At a whole, how is your building performing? But if you want to dive deep into specifically for electricity, the client is looking for 10% reduction, natural gas 5%. That is a place where you need to use level 2 analysis.
for gas emissions?
Yes.
I don't know if this is the case. If they account for different electricity sources.
Yes, it does. So if you, that will something I will be showing, but since you already asked, if you, right now it won't show up because we haven't developed our model yet, but I will be showing in next few minutes of about the emission and how it takes, it does, but it does take into consideration the source of electricity based on the utility or the location of your project. Yeah. Okay, so now we will be going into anyone on Zoom call who has any questions? How do I see? Okay, up to you. Sorry. Anyone, any questions? Can you please repeat the questions as they are asked? Oh, okay, sorry. The question that was asked by one of the attendee out here was for the benchmarking. I think the question was, sorry.
Oh yeah, the difference between
Yeah, difference between level 1 and level 2 analysis. So level 1 is specifically if you want to do benchmarking at a property level, doesn't matter how, the client doesn't have electricity and natural gas separate goals in terms of energy savings. That is a place where you use level 1. Level 2 is like you want to dive deep into each source of energy for electricity, natural gas. If you have any other source and you know the fuel consumption, you can accordingly at each fuel source, you can benchmark your consumption. Okay. Now we dive into the second part. That is, now you are in this space. Now you saw there is a very good energy optimization opportunity for this space. The first thing that you identified, all the lamps out here are halogen. One easiest way to do it, upgrade to LED, right? So for our project, we have an office space in the building is lighted with halogen fixtures. You are proposing to switch to LED. So now the client is asking, what is the energy saving associated with that, right? What is my payback? That this will be the questions that the client will be concerned about, right? So now we will be doing that analysis. So in our base case, we have 20 halogen pot lamps that each of 40 watts. It is operating for 12 hours per day. And we need to set the heating cooling impact to 0. So I will be explaining what that means. So we go into our RETScreen file. We go into the energy tab. We go, now lighting is one of the end uses in the building, right? So what I will do is I will go into the energy tab. I will select lights. Okay, so I will give a name like I'm doing a lighting upgrade, right? So now again in lighting, there are two ways you can estimate savings. First is by if you have watt per square feet for the space, that is a place where you can estimate what is the reduction in watt per square feet. In our case, they have given the exact count of fixtures, right? So that is a place I will go into the level 2 analysis. So in this case, I will assume there is no illumination level that is required in this. So that is something I won't be doing as part of this analysis. But over here, you can certainly, depending upon what type of space you have, so RETScreen gives you an estimate range of the foot candle that is required in that space type. And you can select for the two different case, halogen versus fluorescent or LED. What is the difference in my foot candle or illumination level? In this case, we won't be doing that. It is not required for our analysis today. So in our base case, we have a halogen lamp. Again, the electricity load per lamp. So they have given it as a 40 watt per lamp. They haven't mentioned anything about miscellaneous losses, so I will assume it is 0. The number of fixtures that they have mentioned, there are 20 halogen lamps. So there are 20 lamps and it is operating 12 hours per day, right? So now this gives me what is the electricity being consumed by halogen lamps that is operating for 12 hours per day. It is consuming 4,380 kilowatt hours of electricity annually, right? In the question they have asked, like set the heating cooling impact to 0. As everyone knows, whenever a lighting is not 100% efficient. Any lighting that you have, it gets certain percentage of that gets converted into heat, right? And that heat impacts the overall heating cooling load for your building. If you are in your summer months, it will impact your cooling load, right? Because now the space, the chillers needs to do more work to provide cooling into the space. But if you are in winter, it will be used for heating the space. So in our RETScreen, they have asked to make it as 0. We are assuming the halogen lamps has no impact on your heating cooling load. That is what we are considering out here. In our proposed case, they have asked, we are upgrading this to LED. So I will consider LED. My proposed case, we are replacing it with a screw-in type 8 watt LED lamps. So my wattage per lamp is 8 watts. Miscellaneous loss is 0. I'm assuming it's the same quantity and it is operating for same hours. So now RETScreen gave me a quick analysis. What is my energy saving associated with lighting upgrade? So we are reducing by 84%, right? Another thing that given is incremental cost for replacement. They have given it is $300 lamps and labor. So that's the total cost for implementing that measures. So this is a place where you can include your cost. That is the initial cost for implementing the measure. And if there is O&M cost, that is a place where you can enter out here. And so if you go into the include measure tab, this is a place where you get the overall summary in terms of what is my electricity saved, what was my cost for implementation, what is my fuel cost savings, that is my utility bill savings, and what is my payback, right? Payback of 0.6 for this lighting upgrade. And if you go into, so there are multiple ways you can see like what is my energy consumed in my base case and energy saved. Yeah, energy saved is this one. This is my base load consumption, right? This is for my proposed case. Okay, you go into include measure. Yeah. Yeah, and depending upon what you want to look, energy and fuel. Fuel is taking into consideration the efficiency of the equipment. Okay. Over here, I want to estimate what is the saving. So this is my report that I can share with the client. Like if you want to do a lighting upgrade over here, this is a payback. This is the energy saving and the cost savings associated with it. A quick analysis, right? Any questions? Anyone? Okay, come on. Okay, so this is a place where all the questions like what is our savings? Savings is 3679. What is the dollar savings? It is 515 for the fuel cost, and my payback is 0.6 years. Okay. Third part is now HVAC. Okay, so this space is cooled by a rooftop unit. It has a furnace that is having a seasonal efficiency of 80%. It is a gas fired furnace, and they have a compressor that is having a seasonal COP of 3, right? And they have given multiple information in terms of how this rooftop unit is working, how much airflow it is bringing, and multiple information. So now we will be setting up the HVAC system. So they have mentioned it is providing ventilation. So what I will do is first they've given there is a furnace. So what I will do is that is a type of equipment for us, right? So I will go into the heating. So these are the different equipment that you can select for heating, right? Depending upon project that you work, it could have heat pumps, it could have water heater, it could have a boiler, it could have a district heating. Depending upon what your source for heating is, you can select. In our case, it is a furnace. It is a natural gas fired furnace, and they have mentioned like the seasonal efficiency is 80%, right? Now, suppose if you go on an energy audit, you don't have, this is something that we see many times, right? Like if you go into an old building, they don't have drawings, the building engineer doesn't know what the efficiency is, or they don't have the nameplate picture as well. So how do we estimate? RETScreen has a very good database. Like if you select the seasonal efficiency, that is a place where they have given sort of a reference that you can use. You can select this, the one in blue, and it gives you a very good estimate, like a range that you can consider depending upon what type of system you have. Depending, is it a standard, mid efficiency, high efficiency? Is it a electric resistance? Is it a heat pump, air source or ground source? So they have given you a good range of efficiency that you can consider for your analysis. So in our case, they have already given 80%, but if you work on any energy audit project you don't know, you can take this as a reference to get started with. Another thing to consider, yes, no worries, yeah. Yes, so if you select seasonal efficiency, yes, and there is a blue hyperlink that will take you to that table. Another thing, like if you come across a project or rather RETScreen, you don't know what is the information that they are looking for. So for each tab, or rather each text, they have given a definition about it. So if you want to understand what it means, what information that RETScreen is looking for your analysis, you can read description about that. And if you have an energy audit project where you want, like the client is looking for detailed information, you can also specify about the manufacturer, model number of units. Again, since the cells are in gray color, it is not taken into consideration for your analysis. But I mean, if your seniors are reviewing your work, they can take this as an example. From where did you get this information, right? There could be places where you got this information from an online source and you want to save that document. You can select show notes, and that is a place where you can type in all the link or anything as a reference for future records. So in our case, we have a seasonal efficiency of 80%. We have a compressor that is a COP of 3. So I will go into the cooling. I will select, again, there are multiple types of ways we can do cooling. I will select a compressor. It is electricity and it is a COP. So I will select, so there are two ways efficiency is rated in for cooling equipment, either SEER or COP. In our case, it is COP, and I will consider 3. Right. So I have set up my equipment. I have set up my rooftop unit. So this is the for RTU. This is the furnace for RTU, right? So I have modeled my rooftop unit now. Now they have asked us to estimate what is the energy consumed by this rooftop unit for this space, right? So what I will do is the building is cooled to 72 degree Fahrenheit on the same schedule as the heating. So cooling set point is 72. The schedule is same as heating. So I will assume it is operating 24/7. The rooftop unit has a airflow capacity of 5000 CFM and provides ventilation, heating, and cooling as required. Okay. So what I will do is I will go into the end uses, energy, ventilation, and since it is 24/7, I will assume it is 24 out here. It is supplying a total of 5000 CFM, right? And it is providing heating and cooling both, right? That is what is provided in the information out here. So over here in the system selection, it is providing heating and cooling, right? Where the rooftop unit is providing 20% outside air, right? So the fresh air intake is 20% of 5000. Over here, they are asking in percentage. So I will just enter 20% out here. Okay. The fan is driven by a 5 HP motor. So in this ventilation calculation, the rooftop unit, I mean, RETScreen can only estimate what is a heating, cooling, energy consumption by the rooftop unit. It cannot estimate what is a fan energy consumption. I mean, the fan motor energy consumption. So for that, we need to do a separate model. So what we will do is that is a separate end use. So we go into the energy tab. We are still now setting up a fan for that rooftop unit, right? So this is a fan. It is a 5 HP. No need for manufacturer model number. Load factor. Now they haven't given anything about the load factor. I don't know what should I consider. So what I will do is I will select what is RETScreen typical values, right? So as per RETScreen, the typical range is in the range like 60 to 75%. The user should enter 100% if the motor is operating at a rated capacity during the operating hours. I will assume it is not operating at rated capacity. I will assume as 65% load factor. Depending upon what type of fan blade we have, there are multiple options. That is something we should be looking into the spec sheet. Efficiency, again, I don't know the efficiency for that fan. So I will go into the typical values. And depending upon what type of fan blade I have selected out here, I can assume in the range of 60 to 70. So I will assume average of those 65, right? And set the heating cooling impact to be 0. Right. Next, it is the fan and ventilation operates 24/7. That is a constant volume, right? So it is operating 24 hours and it is a constant flow, right? So this is something is my baseline energy consumption for the model, for the supply fan motor, right? And this is for the heating and cooling being done by the rooftop unit, two separate things, right? Over here, they have also told the dampers have a medium leakage. So the intake damper, the outside air that it brings in, it is having a medium leakage out here. And the heat, there is no heat recovery. So I will assume this is 0. Another thing that they have mentioned, it is a constant fan control for the ventilation. So both are constant. Another thing that we haven't considered is the system reheat. System reheat is, suppose if you have a rooftop unit and before it enters a space, there is a small terminal unit like variable air volume, fan powered boxes with reheat. So those are the different types of terminal units that adjusts the amount of airflow and the heating cooling supply air depending upon the thermostat set points, right? Suppose if you have a rooftop unit that is serving two spaces, this one and the other one. This is calling for cooling, the other one is calling for heating, right? The roof, what will rooftop unit do in that case? It will always supply at 55, but the VAV out here, the terminal units, there is a reheat coil attached with it. So it will adjust the supply air based on the set points that is there in the space. And for that one, it is going the cooling mode. So that is the question out here. Is there a reheat in your terminal unit or not? Right? So in our case, they have not given anything about the terminal unit. So I will assume there is no reheat happening at my terminal unit level. So this is my base load energy consumption. Again, this is in kBTU. Okay, so I've selected kBTU of energy consumed, and this is my base load energy consumption. Any questions on how to set up a HVAC system? Suppose if you have a makeup air unit. Makeup air unit is something that brings in 100% outside air. So in that case, my fresh air will be 100%. Right? Same with the DOAS system. If you have a DOAS system with heat recovery wheel, that is a place I will have my heat recovery efficiency. Right? If you have a terminal unit with reheat, so that is a place I will set my system to be yes. If you have a HVAC system that is providing only cooling, right? So in that case, I will select only cooling, right? So there are multiple ways you can set up depending upon how the design is for your property, right? So this is my base load energy consumption that I have set based on the information provided. Now in the proposed case, I see the one as an energy auditor, I am recommending if the space, this is an office space, it won't be occupied 24/7. Why are you operating so like during unoccupied hours? So what I will recommend to the client is, why don't you implement a scheduling measure, right? Or optimum start stop, right? Optimum start stop, is everyone aware about optimum start stop? What it is? No? Okay. Optimum start stop is sort of a control measure where the building management system, like the controls, will decide what is the best time to start your system. Okay. So right now, the way it is industry operates, the building engineer who maintains the building, he decides, okay, tomorrow the temperature is pretty cold. Let me start my system little at early, like 4 a.m. It is based on guess or experience. But over here, optimum start stop is something the controls will decide what is the best time to start. It takes into consideration multiple systems. So it takes what is the set point you want to reach, what is the outside temperature, right? When is the building going to be occupied? Like at what time are your tenants going to be in the space? Like suppose if you have this space where the tenant will be coming at 8 a.m. and you want the system to reach 72°F by 8 a.m. Right? Now the building management or the controls will calculate what is your heating or cooling load, what is my outside temperature, and estimate how much early do I need to start my system to reach 72°F by 8 a.m. Right? It could be, sometimes it could be 1.5 hours early it needs to start. Sometimes it could be 30 minutes. Sometimes it could be 3 hours as well. Right? So depending upon what the saving, difference is, you are saving energy. Instead of having a fixed start at 5 a.m. all the time, now you are saving depending upon the ambient temperature and the load in the building, right? So that is what we are implementing out here. The building is occupied for 10 hours per day and 6 days per week, right? So what I will do is I will set a new schedule. So I will go into the schedule tab out here. So my new schedule, it is 10 hours per day and 6 days per week. So it doesn't specify. So 6 days, is it from Monday to Saturday or Tuesday to Sunday? RETScreen doesn't take that into consideration. It just takes the total operating hours. Okay. So I will assume it is Monday to Saturday. It is operating 10 hours per day. Okay. Next, modify the fan and ventilation control to operate according to the schedule. That is 6 days per week, and you will need to add a schedule. Okay, that is something we done. So now we set a new schedule, and we want the ventilation to operate based on this schedule. That is what they have asked to modify the control. Second measure that we are implementing out here is implementing a nighttime setback. So usually during occupied hours, the building has a set point of 68 and 72. But when there is no one in the space, why should I maintain 68 and 72°F in the space, right? I could potentially make it like 60 and 80 for heating 60 and cooling 80. So I'm saving energy out there, right? I am not letting my system to turn on when there is no one in the building. So that is something that we are doing, nighttime setback. So which means during nighttime, I want my temperature to go on a safer side, like conserve energy. So they have asked to have a 4 degree of dead band for that. So my current set point is 68. So with 4 degree minus, it will be 64. And for cooling side, it will be plus. So 72 is my current set point. My proposed will be 76. Oops, sorry. This is for the occupied. Sorry. For my unoccupied, It is 64 and 76. Does this make sense? Any questions on this? What is the meaning of nighttime setback and why? So the way the system operates, let me give you a good example. Like suppose if this is a space, my set point is 68 and 72. My space right now is at 65 degrees Fahrenheit. What will happen? I want my zone, this space to be between 68 and 72, but right now it is at 65. What should happen? Should it go in heating or cooling mode? Sorry. Right now it's 65. I want it to be 68. Heating, right? Yeah, so I want my temperature to go up. So what I will do is I will start my heating, right? The other way around. If my set point is, my space is currently at 76, but I want 72, what should happen? Cooling mode, right? I want to reduce my temperature, so I will cool down. Between 68 and 72, it is known as satisfied condition, which means there is neither heating or cooling happening. It is just providing that much air, right? Now, in unoccupied, right, there is no one in the space. I don't want to maintain 68, right? What I can do is I can save electricity and natural gas by changing my set points to be on a safer side. So what I can do is I can reduce it to 64. So now what will happen? Between 64 and 76, my system is now not operating. I mean, it is saving energy for me then. Make sense? So only time my system will turn on is when my space temperature goes either below 64 or above 76. So that 8 degree of difference is the savings that I'm getting for my electricity and natural gas. Make sense? Okay. And the last measure that we have, last information that we have is the cost for controls for implementing this entire controls is $3,000. So first I will load all this information. So we have on the proposed case for the ventilation, it is on a schedule. Okay, sorry, one more thing in the schedule. We can't leave this as blank. So Sunday, enter it as 0, or else it will give you error in your calculation. So just enter this as 0 out here. So in your ventilation, I want my proposed case, like the solution that I'm giving to the client is implement this optimum start stop sequence and also nighttime setback, right? It is for the same airflow, same outside air. There is no reheat. It is providing heating and cooling. And my dampers, I haven't fixed my dampers, and there is no reheat. Sorry, no heat recovery rather. So this is the savings associated with nighttime setback and implementing the scheduling. But again, this is not everything. Do you know what is missing? So we implemented the nighttime setback. So we did heating, cooling, energy savings. But what about the ventilation for the fan motor? We did not consider the reduction in the operating hours for the motors, right? So that is something we will be doing now. So we go into the fans. Again, same information. It is at 65, but now it is operating at 60 hours per week. Initially, it was operating 24/7. So what I will do is I will select hours per week, 60 hours. So this is my fan motor energy savings, right? The one that we saw in the ventilation, it was heating and cooling savings. The one I'm seeing in the fans is my fan motor savings. Does that make sense? Okay. And if I want to show to the client, like what is the total energy saved? Okay, I think we haven't included the $3,000 cost. So that is my cost for implementing this control measure. So I will go into the include measure tab and I will see the overall payback for implementing lighting upgrade and the controls for my rooftop unit. It is 0.7. I'm saving 4,120 for heating. Okay, this is in kBTU, 14,057 kBTUs. For my cooling energy, I'm saving almost 1700 and my electricity savings is 1950, 19582. Any questions on this? How did we do? Like suppose if you have a client who is like, I don't want to do lighting upgrade, I just want to do controls. What you can do is you can remove that measure and still get the savings only specific for one particular measure, right? Or if there is a, they just want to look at lighting savings. So you can get a quick update from that, right? Any questions?
Can I see your
Yes. So the changes that we made in our proposed case is one is scheduling. I'm assuming we implemented optimum start stop, and we also implemented the nighttime setback. So that is the heating cooling savings that I'm getting for my system. Just check your metric system as well. Is it in KBT or? Any questions online? Does everyone online, are they getting same answers or any different answers? One thing that we missed out was what is the efficiency on my proposed case, right? So I'm assuming it's the same efficiency out here as well. My furnace is same efficiency and same for my cooling load. So that should be taken into consideration as well. Interactive, yeah, that is something we will discuss. There is one more thing.
But LEDs are not there. You save up on electricity, but that heat is being used by the space. Now you have to heat the space a lot more.
But why is it negative 32,000? He's getting 14,000. Like,
did you
Is she getting negative? Okay, the reason for that, if you go into the schedule, you might have selected degree Celsius.
It's because she does not have the efficiency.
Oh.
The efficiency for
80%.
plant. You need efficiency. That's why it's not. Same for compressor.
So the question that we have in the audience out here, they are getting negative savings, probably because they haven't put the efficiency for the proposed case.
Let's let Hardik continue his study session where we can discuss.
Yes. Yeah, one thing that I forgot to share. So RETScreen as a software, it considers interactive effects. Interactive means, suppose if I'm implementing one of the measure, what is the impact of that measure on the energy savings for the other measure that I implemented? Like suppose if I implemented lighting upgrade, it will change my heating cooling load, right? And now I'm implementing a controls measure for my rooftop unit. So that will have an impact on my heating cooling load. So RETScreen takes into consideration if you're doing multiple energy efficiency project, the total savings that you're getting is considering the interactive effect of all and not individual measure. What is the influence of one measure on the other? So it takes into consideration that. Okay, so next we have is VFD for your pump system. Okay, so there is a office space where there is a pump that is working on a constant volume. Now you want to do a variable volume and want to do a financial analysis associated with that. So that is something we will learn. So we will go into the energy tab. We will select the pumps. So they have mentioned a 50 HP standard efficiency motor, load factor of 75%. So my motor is of 50 HP of standard efficiency and a load factor of 75%, right? My pump is 50% efficient, variable flow pump operating 90 hours per week. So my pump is 50% efficient. It is operating 90 hours per week. So what I will do is I will select the drop down per week, 90 hours, right? They have mentioned it is a variable flow type. So what I will do is instead of a constant volume, it is a variable volume, right? And they have mentioned it operates at a high flow range. So my flow range is high and it is a throttle flow control. So I will select a throttling type. So I got my baseline energy consumption for my pumps. So what is the difference between a high and a low flow range, right? So if you select flow range, if the system is used most of the time below 50% of the full flow capacity, the user should and select a low flow type. Otherwise, it is a high flow type. If a pump is designed to operate at 500 GPM, and if it is operating at 100 GPM all the time, like 50% of the time, that is a place I will select a low. And if it is operating above that, it is a high, right? So this is my baseline case. Now the client is like, no, I want a variable frequency drive. What is the savings associated with that? And give me a financial report. I'm not a technical person. I want a financial analysis. When I'm getting my payback, what is my equity? What are the incentives available? So I want a detailed analysis, right? So in that case, the client is like, I want to change my pump to premium efficiency as well. So I'm changing my pumps, like upgrading my pumps to a premium efficiency motor. So you see that the efficiency changed from 91.1 to 94. Again, this is from the database that RETScreen has. If you have the actual efficiency for the pumps, or rather the motor, you should be entering that to get the actual savings associated with it. The efficiency for the pumps, there is no change in that. And it is a variable. It is the flow control is a variable speed. So over here, I'm changing it. I'm installing a VFD and it is at a high flow range as well. And I'm installing a VFD drive and it is operating for the same operating hours. So there is a 40.7% savings associated with installing a VFD. But the client is looking for financial analysis. So what I will do is client is looking for financial analysis specifically for VFD and not for all the measures, right? So what I will do is I will first unselect everything and just select the pumps. That is what the client is interested in, right? Now I will be going into my finance tab. Okay, so the information that the client uses for their financial analysis internally is they have a discounted rate of 5%. Okay, one thing that I wanted. So again, there are level 1 and level 2 in financial analysis as well, depending upon how detailed the client is expecting in terms of the reporting. So level 1 includes the inflation rate, project life, debt ratio, interest rate, what are the grants or incentives that are available, and it will give you a quick analysis. But if the client is like, no, give me like a detailed analysis on the finances aspect, so that is a place where we use the level 2 analysis, and it gives you graphical information, the financial viability, all the financial information that the client is looking for. So in our case, there is a discount rate of 5%. So discount rate is 5. My reinvestment rate is 5%. I won't be diving into what each and every term is out here. So inflation rate is 2%. That is 2. And my inflation rate for energy is 4%. Right? So my energy inflation rate, fuel cost escalation rate is 4%. I'm assuming my project life is 20 years. And incentives. So they have mentioned ComEd, one of the utility provider in the Chicago region. They are currently giving you $200 per HP for upgrading to VFD. We have a 50 HP motor. So we are getting almost $10,000 from ComEd as an incentives, right? So we will do two types of analysis. One, without the incentives, what is my payback? And after getting the incentives, what is my payback? So that is a difference I can show to the client, like the advantage of going with the incentives, right? So I will assume like the same other default values for the interest rate and all this stuff. And if you want to do a income tax analysis, you can do over here. So, sorry, one thing. One thing that we missed out was the cost. The initial cost is $12,000 for implementing this measure, right? So now I go to the finance. Okay, so now the client, if the client makes an investment of $12,000 for upgrading the VFD, they are having a payback of 1.5 years without the ComEd incentives, right? That is associated with the energy savings that they are getting. Now let's see what is the change if they get incentives. They are getting a $10,000 incentives. Their payback is 0.25, right? So this is something that we can show to the client, like why it is a good fit for them to upgrade to VFD. Though there is a capital improvement measure, but there are good incentives available in the market, so better take an advantage of that. And they are already getting positive cash flow once they implement the measure, right? And this is also the place where you can see what is the reduction in their GHG emissions. That is 572 USD per ton of CO2 saved. And if you are looking for a detailed GHG emissions, you go into the emissions tab. Specifically for doing a VFD upgrade, this is a place where you can show to the client like what is a GHG savings associated with it. And again, as you asked, like if it is, sorry, you had asked about the location. So this is a place where specifically for the state of Illinois, or depending upon where your project is, you can select the GHG emission factor. But if you have a specific metric that you use as a different database, you can certainly update that and get the actual GHG emission for your project. Again, in emissions, there is level 2, level 3, depending upon how detailed you want to go. It's a different level of analysis, but to keep it simple, we can do with level 1. Any questions in this? Yes.
What is the difference between level 2?
For which one?
For missions.
Yeah, level 1, high level, pretty straightforward, right? Level 2 is a place where depending upon for each fuel source, what is my fuel mix, what is my electricity generation efficiency. Like suppose if you have like multiple sources, like you have all the detailed information from the utility as well. That is a place where you can enter the information for each fuel source. And again, in level 3, it is again one step ahead, where you get the GHG emissions and everything associated with it. I think it's in level 2 as well, but it's
You can change the CO2 emissions factor. So if
Oh, yeah,
know
yeah,
exactly
that
what
is-
the emission factor is for that fuel.
Yeah.
Because it changes based on regions. You can enter that.
Oh, okay.
Okay, any questions for VFD upgrade? There is one last thing that I will be teaching, and then we will be taking a 10 minutes break. And then Hithen will be teaching us, we will be doing a case study based on the things that we have learned today. Okay, so last thing that we will be learning from my end is, now I have done everything for the HVAC, lighting, VFD upgrade, but what about the building envelope, right? The building exterior, like the walls, windows, doors, roof, floor, even that impacts the overall performance of your building energy, right? So now we will be modeling building envelope in this. So we go into the energy tab, the building envelope, right? So now the first information that they were provided, the building, the north face of the building is oriented 30° west of the actual north. Okay. So now let's understand from RETScreen perspective how to enter that. So if you select building north, they will give you a definition how to enter that value in RETScreen. The user enters the angle measured in degrees between the north face of the building and the true north, that is the polar north versus the building's north, right? Buildings with north face directed 10° east are entered as +10, and buildings with north face directed 10° west is -10, right? So in our case, the building is oriented 30° west, so it will be -30, correct? So as per RETScreen, we need to enter this as -30, right? Next, they have given the building floor area and roof area is 100 by 100 square feet or 10,000, sorry, 100 by 100 feet or 10,000 square feet, right? So what I will do is, I have the roof area that is of 10,000 square feet, and I have my floor area that is 100 by 100. So the perimeter for a square is 4 times the side of the square, right? So that is 400 square feet. That is my perimeter. I will enter that information later. I will explain why I am doing that. Next, the wall height is 20 feet for the building volume of 200,000 square feet. So a cubic feet, that is the volume for the building, right? So what I will do is, I will go into the infiltration tab and air change rate. That is a place where I can enter the 200,000, that is my volume for the building. So there are multiple ways, there are multiple factors that impacts the building envelope. So it includes, so the things that we have is, first is the orientation of the building, right? Second, walls. If there is a window, that is associated with that. We have doors, we have roof, we have the floors. If you have a basement, that there is floor below grade. The meaning of grade, below grade and above grade, anything that is below the ground level is considered as below grade. Okay, anything above the ground level is considered as above grade. Okay, so if you have a parking lot that is in the basement, that is below grade. If you have a outdoor parking lot, that is above grade. Make sense, the difference? Okay. So we have the volume 200,000 square cubic meter. The east, north, all the walls, east, west, north, south is 2,000 square feet. So my walls each is 2,000 square feet. My walls and roof has an R value of 8 square feet degree Fahrenheit per BTU R. I would highly recommend looking into the units because it always creates a confusion. So in our case, it is an R value of 8. If you change the units, it will give you U value. So depending upon what information you have, you can enter that information out here, right? And same for my roof as well. My R value is 8. Okay. Now they have given floor is uninsulated on slab grade. So my floor is below grade. We mentioned about the perimeter, that is 400 square feet, sorry, feet, and it is uninsulated on grade. right? So by default, my R value is coming out to this one. This is from RETScreen database. Does it make sense? Any questions so far? Next, they have mentioned my north wall is having a door and it is occupying 10% of my wall area. So my doors on the north side is having a 10% area. And the windows, sorry, the south has a window area of 200. So the window is on my south side, 200 square feet. And the windows and doors has an R value of 2. Oops, sorry, this is in percentage. So R value of 2 for my windows and for my doors. There is no solar shading, so I will uncheck that option. And they haven't given anything about solar heat gain. So I can either refer to the ASHRAE standards for a particular window, or I can refer to the RETScreen database. So depending upon what type of window, is it a fixed window or an operable window? Operable is something that you can open and close. Fixed is, it doesn't move. So I will assume it is a operable window. So my total window solar heat gain coefficient, I'm assuming it is a double pane window. It is 0.55. I'm just assuming that it is not provided. I'm just assuming it is a 0.55 solar heat gain coefficient. Right. And last, they have given the air change rate of 0.4. Right. And it is impacting my heating cooling load. So this is my baseline heating and cooling energy consumption for my building based on the properties that I have defined for my wall, windows, doors, roof, the air leakage, and the floors. Make sense? And now I'm not doing any upgrade on this one, right? So one of the easiest way to transfer all the information from baseline to proposed is the tab out here, copy base to proposed. The one on the top, if you select that, you can in one go, you can transfer all your information from baseline to propose. No need to enter manually everything. Or you could also do propose to base if you want to do the other way around. Right? So since my baseline and proposed is same, there won't be any energy savings. That is something I can confirm. Make sense? Okay, any questions on this? So we learned about benchmarking, how to set up HVAC system. We learned about the building envelope. We learned about the lighting upgrades. If there is a control measure that we are implementing, how to do that. If I'm installing a VFD, how to do financial analysis. So we learned about the multiple aspect on how RETScreen could be used for all your projects. But yeah, so now we will be taking a 10 minutes break. But if you have any questions, I'm available out here.
All right. Are we ready? Attendees who are online, I hope you had a good break. So did all of you. Got some time probably to stretch, use restroom, have some coffee. Without wasting any time, we can get right in. Quick introductions. My name is Hiten Chajed. I am also an energy and decarbonization project manager at Baumann Consulting. Been with the company for over 3 years now. Also a certified RETScreen expert. I work in the Washington DC office, so most of my projects are in the DMV region, working on energy audits, commissioning, similar to Hardik's profile, but in the DC area, DC Maryland area. I'm going to share my screen, and before I start talking about the case study, want to make sure that everybody received those 2 case studies, 2 RETScreen files from IGA. People online, did you guys receive those files? Because we will need you to pull those up while I walk through the case study. Okay, we're going to walk through 2 case studies. One is a multifamily or a residential property, and another one is an office building. These are actual projects that Hardik and I have worked on in the past. And I will walk through the RETScreen model. There are a lot of pieces that I'll talk about. And I'll just walk through for the next 20 minutes or so, and we'll give you about 40 minutes to work on the proposed case and calculate the energy savings, typical ROI, simple payback, all of it. Okay, let's just dive right into it. The first case study is for a multifamily property. The owner wants to electrify the building. They have the property owner has a decarbonization goal, and they use it's an old building. It was constructed, I think, in 70s. They use a lot of natural gas to mostly heat the building. They have a big huge steam boiler, and they want to electrify it. They want to replace it with heat pumps, more efficient systems using electricity, get rid of any fossil fuels that's burnt on site. So that's the goal. And in their efforts to electrify, they also want to replace their existing domestic hot water system. So they have a central hot water boiler or heater that uses natural gas and supplies hot water to different units in the building. There are about 50 units, all 1 bedrooms. That's the basic background for the building. I have a few, some information here. There's a boiler. We have the efficiency. There's no central cooling system. Each unit has individual window ACs, and it has particular efficiency value. We have averaged it out to a CR of 12. Proposed case, what the owner is proposing is to take out the boiler, take out the window AC, and install air source heat pumps in individual units, and get rid of the natural gas for heating. We have the efficiencies for the heat pump, heating and cooling. We have the installed cost, and there's some direction on what costs to use, and I'll get into it in a minute. So before I go to the next part, which is replacing the domestic hot water, I want to open up the model. Actually, while it's opening up, let me talk about the domestic hot water replacement also, so that I can walk through the entire model together. You can see the base case is a natural gas domestic hot water heater. It has an efficiency of 70%. Again, they want to electrify it, meaning no natural gas. So they want to replace it with a heat pump water heater. It's also air sourced. It runs on electricity. There's no natural gas. We have a COP. We have an efficiency for the hot water system. And the quoted price or the installed cost from a vendor is about $350,000 for that system. And we want you to calculate the energy savings for both these scenarios. You can see the kilowatt hour per year savings, natural gas savings, cost savings, and what is the total % of energy savings. And of course, the simple payback. Let's see if the model is, yep. All right. I'll just quickly walk through, the base case or the baseline model. It's a building in DC. We have all the facility information. I've already created the end users, the system, added everything I need to for the building, so that you don't have to add the base case. All you need to do is calculate the energy savings. Under electricity and fuel, you can see that there are 2, electricity and natural gas. Since it's a multifamily building, it's operating 24/7. We have the set points, we have the changeover temperatures. Under heating, you can see that there's a boiler with the efficiency that was also in the case study PDF. Water heater with an efficiency of 70%. For now, you can ignore the process heat because we want to only focus on the boiler and the heating and the cooling of the building. Under cooling, the compressor essentially means the window AC units that they have. And you can switch the efficiency rating, you can switch it from COP to SEER. These are just two different units that you use to calculate what the efficiency of the system is. So for the base case, for window AC units, it's a SEER of 12. And then we have the building envelope. Again, we've walked through it in our previous, or before the break. We have the wall areas, we have the window areas, we have all the information entered, and this information is directly coming from the drawings of the property. The building is heated and cooled. It's assigned a boiler. It's assigned the window AC units, and it calculates the total heating and cooling energy for the building. We've entered all the lights, hallway, stairwell, basement lights, unit lights, exterior lights, but for this case study, you're only going to focus on the heating and cooling. For the hot water, we have entered as an end use how much hot water the building uses. We know, we've calculated, we've used the RETScreen recommended values for the apartment. It's about 1325 gallons per day. We have entered all the information in here, and again, we don't need to walk through every detail. We've assigned it a water heater and calculated how much energy is used in heating or in domestic hot water. So just as a tip, all you would need to do is change the system and the efficiencies in the proposed case for boiler, water heater, and the cooling compressor. This is all you need to do, and calculate the energy savings, and of course also calculate the cost. Once you've done that, you would go on the include measure tab, and you will see the costs, the fuel cost savings, the simple payback, and you can select each measure individually. So if you're calculating only the electrification of central boiler, you're replacing the boiler and window ACs, you just check the boiler and compressor. And right now it's 0 because we've not entered anything in the proposed case. We've not replaced the system yet. So it's all 0. But once you enter, you'll have different values for cost, fuel cost saving, simple payback. And when you can uncheck these two. When you're working on the water heater, you just check the water heater, update the proposed case values, and you'll get the new or the savings number. And at the end, there's a question for final results, which is the project savings. So both of these measures combined, what is the energy savings and the cost savings for the project, for which you will have to check all the equipment. So boiler, water heater, and compressor, and the RETScreen software will combine the savings, and at the bottom you can get the total cost savings, energy savings, and payback. Any questions for the multifamily case study? Okay. Let me open the office, and while it's opening, I'll just give you a quick background about the second case study. This one is a commercial building. It's a 12-story building, office building, and the owner has certain ESG targets. And to meet those targets, he has planned a renovation, an entire office renovation. The first part of the renovation is going to upgrade all the lighting in the building. Currently, they have all fluorescent T8s. It's actually very similar to what you see right here, but I think these could be LEDs. But the owner wants to replace the fluorescent lights with LEDs. And lighting is a major contributor in that building because it's, well, very old, and these are all fluorescent T8s. The building is already running all electric. There's no natural gas. And the next thing the owner wants to implement is replacing the existing windows. They have double pane windows, and the owner wants to replace it with triple pane windows because it's essentially entirely a glass building. So there's a lot of solar heat gain. And there's been some thermal comfort issues, and the owner wants to replace the double pane with triple pane so that there's this, the thermal comfort increases. There will be also energy savings, but the intent or the intention is mostly to increase thermal comfort. We have some base case numbers here, and let me just pull up the office building. There you go. For this, we are not worried about the central system as much as we are as we want to look at the lighting and the building envelope. So In lighting, we have 3 different end users. We have all the floors. So these are all the office lighting. You can see there are fluorescent T8s with 32 watts and 3 lamps per fixture. So similar to what we have in this room, I can see that there are 2 lamps. We have 3 lamps for each fixture. These fluorescent T8s, because they are so old, they also have some miscellaneous losses. Losses are assumed to be 10 watts. There are 70 fixtures on a single floor, and there are a total of 12 floors in the building. And that gives you around 324,000 kilowatt hour for just the floor lighting. Then you also have the exterior lighting. These are metal halides, 175 watts, and it's all in the worksheet also. Exterior lighting, 175 watts mercury halide with 10 watts of losses, total of 24 fixtures. So 175 watts, 10 watt losses, and total of 24 fixtures. Next is the stairwell lighting. We have 2 lamp, 32 watt T8, similar to what you have in the office space, but there's 1 floor per fixture. So you have 32 watts, 2 lamps per fixture, and 12 floors, so 12 units. Any questions so far about the lighting part? For the proposed case, now, all you have to do is replace the fluorescent lighting with LED. You have you're replacing the office lights. Those are the fluorescent lamps with 12 watt LED lamps. We have the installed cost for each fixture. For the exterior lights, we are replacing the 175 watt mercury halide with 54 watts LED with daylight sensors, right? So right now, these exterior lights are on 24/7, and I can show you that right here. So operating hours are 24 hours. And in a typical building, you don't need the exterior lights to be on 24/7. You can install daylight sensors or photo cells, so that they go off or at least dim down when it's daylight outside. For now, we want you to assume that upon installation of daylight sensors, the runtime reduces by 50%. So it's not running during the day, it's only running during the night, and assumption is it's running only 50% of the time. So 24 hours becomes 12 hours. And then the third is to replace the stairwell lighting with 8 watt LED lamps, and we have the fixture cost also for that. So that would be the first measure to implement in the office renovation case study. And the next scenario, or the next measure, is window replacement. Once you've entered, or once you've replaced all the lights, we want you to go to the building envelope. We have all the, oh, sorry. Thank you. Where was I? Building envelope. We have all the numbers entered already. This is the base case. We have the U values of the window, which essentially tells you how efficient the window is. We have the solar heat gain coefficient. And again, as Hardik pointed out in the session previously, you can click on the text itself and there'll be some blue text. So these are fixed windows. Office buildings are generally fixed windows. You want to click on typical values for fixed windows. And then you have the table. Right now they are double pane. And what they're installing is the last row in this table, which is triple pane, low E argon plus 2 pyrolytic windows. And I want you to use the total window value, not the center of glazing, the last column, and these values essentially. So that's the first row is your base case, or what's currently in the building. And the last row is what the owner plans to replace it with. So you can use those values, enter it in the proposed case. So what you will change is the U value, which are these numbers, assuming they're same on each face of the building, and solar heat gain coefficient, which should also be in this table right here, SHGC, for triple pane low E argon, which is 0.41. I know I've thrown a lot of information at you. And again, you have about 45 minutes to complete the assignment. So any questions, let me know. Before I let you start working on the assignment, just one quick, let me go back to the assignment. Okay, similar to the previous case study, just enter your savings dollar per year, total percent of total energy savings, simple payback for both measures, and have the final results, checking off both the measures together. The reason we want to first do it separately and then do it together, do you know why we want to calculate both of them together and enter it in total project savings? That goes back to the previous conversation we were having about interactive effects. So both these case studies, if you notice, there's a question called, are there any interactive effects? Yes or no at the end. Even in the first case study, we have a similar question, are there any interactive effects? When you're, just give you a simpler example. If I were to insulate this particular room and make it more tighter, or there's more insulation in the walls, there's less leakage. So the amount of heating and cooling you need is going to be lower. Now, when I'm replacing those lights along with insulating the walls, LED typically would give out less heat than a fluorescent T8 would. So when you replace your fluorescent with LEDs, you save up on your electricity, but you do increase your heating demand in the room because there's less heat emitted from the light itself. So it still makes sense to replace it because the electricity savings is high enough. But both of these measures interact with each other, and the savings might not. Let's say the savings from replacing or insulating the wall was 100 units, but if you replace the lights, it would drop from 100 to, let's say, 80 or 85. I'm just throwing numbers, but these both measures have interactive effects, and RETScreen calculates that. So when you check off under include measure, if two measures have interactive effects and you check both of those measures simultaneously, it will take that into consideration, and your final savings number would not be X plus Y. It'll be lower than that. Yes.
But since like this analysis is focusing on replacements of like existing like appliances or like insulation, is embodied carbon accounted for in the analysis, or is it just like operating cost?
It's just the operating efficiencies. Embodied carbon, I'm not sure. Does RETScreen take it? No, there's no embodied carbon calculation in RETScreen at least. With that, I think we have about 45-50 minutes. You can start the case study. You have those. You can use the same models that we've sent you. You can use the worksheet. We have all the proposed case. We have all the cost values, the efficiency values. You just need to replace into the model and fill the worksheet. All right. We will probably get back in about 30 minutes, and I'll open up the solutions and we'll walk through the solutions together. Okay, let's go through the multifamily case study, which is the first one. Let me pull up. All right. So what do we have? We had a boiler system, just to recap, with a 65% efficiency, window AC units with a CR of 12. We are replacing with air source heat pumps, total of 50 heat pumps with a heating COP of 3.2, cooling COP of 6. So let's go back. Did you guys enter the COP, or did you try to use the product database from RETScreen? Okay. And that's okay. We did not discuss that, but let me show you what it is. Let me first copy base to propose. So this is your this is how it was. This is your base case. If you check your heating equipment, you can just simply change the efficiency to 320% or COP of 3.2. But if you want to use RETScreen database, it also has a list of heat pumps from different manufacturers with different efficiency numbers. You just check the heating equipment box, and you see there's a small button which says product database. Click on that. Now, if you go back to the case study, we've mentioned it's a train TWA unit. Let's see if we can find that one in RETScreen. So first you change the technology, which is from boiler to a heat pump. Under type, this is an air source heat pump. Sorry, it's an air source heat pump. Under manufacturer, you scroll down to train, and let's see what was the model number. It's TWA 120A3. TWA 120A3, and you have 50 units. So you can change the number of units, paste. It gives you all the data, and now you can just simply change the efficiency to 320%. Again, you don't need to do this, but if your client is requesting for particular manufacturer information, you can also use RETScreen database to input that. What's next? We have a cooling COP of 6. So let's go back to RETScreen. Now we go to the, oh, sorry, I did forgot to mention that you have to change your fuel or technology and fuel type from boiler to heat pump. And heat pump is not going to use natural gas, it's going to use electricity. So you change the fuel source, electricity. And that's what your proposed case is for the for the heating system. Now for the cooling system, you go to the compressor. The technology and fuel technology can change to heat pump, but the fuel source or fuel type is going to stay to electricity. I'm going to uncheck this cooling equipment. The COP of performance is being given as 6. So I've entered that as 6. And that finishes off the proposed case for heating and cooling. Now, for the cost, it's recommended that we use RETScreen values or values from RETScreen database, and I'll show you how to do that for average air-cooled systems, and I'll show what that means. So we go back to the boiler. You see this little dollar sign under the equipment. You click on the cost database, and it pulls up this database of costs. You have biomass systems, boiler, furnace, heater, heat pumps, ground source, and air source. For the case study, we are using the air source heat pumps. We are installing air source heat pumps, and we want to use the average cost. So you have 3 ranges: minimum, average, and maximum. For this case study, we are going to use 1520, which is the average cost for an air source heat pump. And you just hit paste data, and that's 1520 and comes up to about 2.7 million US dollars. One thing I do want to mention that in the model, I've already have an exchange rate because this is in Canadian dollars. So I've added although it's much higher now, but the exchange rate is entered as 1.25, and it's US dollars, it's about 2.7 million. But this is only for the heating part. You have to do the same for the cooling part. You click on the dollar value. There's heat pump, again, average cost, which is $680, and I paste the data, and there you go. So we have the cost. But we also need to do that for a water heater. What's the water heater cost? Have you mentioned the water heater cost? Let's scroll down. Actually, we'll get to it in a minute. Were you able to fill out those numbers for the savings for heating and cooling? If not, this is what the numbers are. And let me pull up that again. I go to include measure. I check only the boiler and the compressor because I want to see the savings from replacing the central system. And my cost is about $3.9 million to replace the entire central system and window AC units with heat pumps, air source heat pumps. My fuel cost savings is $15,000 annually. And the payback, you can see, it's negligible. There is no payback. But generally there are goals for different building owners, and they want to electrify because to just give you an example, Washington DC has a building performance standard which requires, or sooner than later it will require buildings to get rid of all fossil fuels burnt on site. So people could do that, building owners could do that for different reasons, although there is sometimes no payback. But the savings number, if you see, how can you see the percent of total savings? You click on comparison on the top, and it brings you to this page that summarizes your savings for you. So you're on the top right, you can see the fuel saved. So natural gas, you've saved about 26,000 therms. Electricity, you've saved, or you've not saved, because now you've electrified the system. So you're using more electricity than you were, but you're saving up on natural gas. You're using 113,000 kilowatt hours more than you were initially, but your total savings is 60.4%, meaning the building, if the building chooses to replace its central system with heat pumps, it will save 60% of its energy that it's using annually. Although there is no real payback in terms of dollar value, but it ends up saving 60 to 61%. So if there are corporate targets that a building has to meet, or if there are performance standards that the building has to meet, 20% reduction, 30% reduction, just replacing the central system in this case can meet those targets. Any questions for the boiler replacement? Okay, let's go to the heat pump water heater. To replace the heat pump water heater, initially we have an efficiency of 70%. So let's go back. We go to water heater. This is, let me first copy paste to propose. So we have an efficiency of 70%, but we are replacing the water heater with a heat pump water heater. So now it's not going to use natural gas. Instead, it's going to use electricity to provide domestic hot water to all units in the building. So I changed that to a heat pump system. I changed the source of fuel from natural gas to electricity, and the efficiency, or the COP, is 3.5, which is, in RETScreen numbers, it's 350%. We have also been given the cost of the project. It's about $350,000. I can just add that number without using RETScreen database. I can just add $350,000 here. Now, if I go to include measure, I see that the numbers have not changed. And this is because I've not checked the water heater. So I uncheck my first measure and I check only the water heater. You can see the incremental costs. The initial cost is $350,000. The project is saving $1,500 annually. Again, there's no payback at all. But how much do you end up saving in percentage? It's about 8.8%. So you lose electricity, you're using more electricity, you save about 4,156 therms. You're using about 25,000 kilowatt hours more than you were, but you're saving almost 9% of total energy, as seen in this table here. Now for the final results, all I need to do is just check both of these measures together. So I checked the boiler, I've already checked water heater, I checked the compressor, which is the cooling part of the project. And now it gives me the total cost, which is about 4.2 million kilowatt for $4.2 million. These are my dollar savings. Again, even combined, there is no real payback, but the total percent savings is almost 70%. So just by replacing or getting rid of fossil fuel like burning equipment, the building can end up saving about 70% of its energy. But because electricity is generally a much more expensive fuel, there is no real payback in these projects. But these two measures don't have any interactive effects between them. Meaning, if I were to, when I replace my boiler with heat pumps, let's say I end up saving 100 units of energy. And if I replace the domestic hot water with heat pump water heater, I end up saving 50 units of energy. I can simply add those two and confidently say that the total savings would be 100 plus 150 because there are no interactive effects between them. So that would answer your final question. Are there any interactive effects? No. These two measures do not interact with each other. Any questions for the first case study? All right. Let's go to the second one. Okay, this is an office renovation. The base case is, we've already established the base case. They have fluorescent lights, mercury halides for exterior, and also fluorescent lights for stairwell. What are they replacing it with? So they're replacing office lights with 12-watt LEDs. Let's go to the lighting section. So this is for the office light. I'm replacing the fluorescent T8s with LED. My electricity load per lamp, or watts, goes down to 12 watt. The number of fixtures stay the same. So I still have 3 lamps per fixture, but there are no miscellaneous losses. So I get rid of this. So just by replacing the office lights, I'm saving 66% of the electricity. The next is replacing exterior lights with 54 watts LED lamps with daylight sensor. So I go to the exterior lights. I change the metal halide to LED. Initially, they had metal halides at 175 watts. I'm now replacing it with a 54 watt LED, assuming there are no miscellaneous losses. But now they also have, these are equipped with daylight sensors. So the 24 hours goes down to 12 hours, assuming there's a 50% reduction in run hours. And that gives, just within the exterior lights, it's a saving of about 85% electricity. Similarly, let's do the stairwell lights. It's 8-watt LED. I have already made those changes. So LED, 8 watts, 2 lamps again. Nothing else changes, just the wattage and the type of fixture. And that's about 78.4% savings. I've already added the costs. Actually, let's add the cost. Install cost for each fixture is $100. So per fixture that they replace, it's about $100. And there are about 70 fixtures. So I'm going to multiply that 70 into 100, which is about $7,000. Oh, sorry, I'm entering into the wrong column. It's the initial cost, $7,000. For exterior lights, it's $250 per fixture. So $250 per fixture. And for stairwell lights, it's $80 per fixture. So I can just enter that in the blue columns, and let's go to include measure. Let's just check the lighting bit. So these 3 measures, I can see on an individual level or on each row what the payback, what the savings is. But if I want to calculate the total savings out of this lighting retrofit, my initial costs are about $90,000. My savings is about $20,000, and my simple payback is about 4.4 years, which is not bad. Any questions for the lighting retrofit? Okay. The last one is the window replacement. The owner wants to replace its windows with double pane to triple pane. And we have the initial or base case U values and the solar heat gain coefficient. In the case study, it's recommended that we use the RETScreen database for U value and solar heat gain coefficient for the proposed case for triple pane, and that's what we are going to do. So let's go back. I would click on U value. And typical values for fixed windows, because this is an office building and generally assuming that these are fixed windows and not operable. And for triple pane plus 2 pyrolytic low E argon windows, the U value is 1.18 and SHGC or solar heat gain coefficient is 0.41. So I'm just going to enter that in my proposed case. But what I have to be very careful about is that the units are in imperial system right now. So I need to change that to metric because the recommended numbers were in the metric system. So now I changed that to, I forgot, 1.18. I changed that for all faces. So north, east, west, and south, 1.18. And my solar heat gain coefficient was 0.41. 0.41. And if I scroll down, I would see the savings in heating and cooling energy by replacing the windows from double pane to triple pane. Now, for the cost, it's also recommended to use a RETScreen database with average value of average installation without insulating edge. So let's go back and again click on the dollar icon and it'll give you all the databases or the RETScreen database. So I'm using, this is not an operable type, this is a fixed type window. I'm going to select the window itself because, and you can select and unselect whatever you want. So when you pull up, this is how it's going to be. I'm replacing the window. I'm adding low E because it's triple pane and argon, but I'm not insulating the edge. So I'm not going to select this. But this is only the window cost. Okay, we were talking about and I hope you can see the screen now. We're talking about pulling the costs from RETScreen database for Windows. So I click on the database. When you open the Windows, this is how it's going to look like. First, I need to select the type of window that I want to replace it with. So I'm replacing with a triple pane window. I'm using the average cost for the windows. Average cost for adding argon, it's low E, but I'm not insulating the edge space. So I'm not going to select the plus 23. I also need to add the cost for installation, which includes labors and other costs. So I select that, but there's nothing on these rows and I just hit apply. And it gives me a dollar value per square feet and the total cost for replacing the windows. Now, if I go to include measure, I want to see the savings from the window replacement. So I uncheck the lights. I go to building envelope. I check the building envelope and these are my numbers. So my initial costs are $640,000. My savings is about $8,000. The payback is about 77.4, which is again, virtually there's no payback. And usually with building enclosure measures, there is no payback. It doesn't save as much as it costs. But if I want to see the percent of energy savings, I click on comparison again. I see that I've saved 76,000 kilowatt hours. I've saved $8,000 and I've saved about 4% of the total energy or total site energy. Any questions so far? No? Okay. And the last question was what the final results are. And now there are interactive effects between these two measures because when you're replacing your windows, your load reduces, which means your savings from the lightings is going to interact with the Windows savings. And it's not going to be 1 + 1 = 2. It's going to be lower than that. For that, to know what the final savings number are, we need to check all the measures that we've implemented. And at the bottom, these are your numbers. So your payback now is 25.1 years with a savings of about $30,000 and investment of $730,000. And if you want to see how much you've saved on a site energy basis, I click on comparison again. I've saved about 14% energy by replacing the lights and replacing the windows. Any questions? All right, I think if that's all, we're going to share the final case study solutions and the worksheet with you after this presentation. Feel free to reach out to Hardik or myself or to IGA if you have any questions. Happy to answer any questions. I think you have a 30-day trial with RETScreen. So, go ahead and play with it. There are virtual energy analyzers, and let me quickly show you how that works. I'm going to share the screen for people who are online since we are on the call. So if you go to file, you see virtual energy analyzer. You click on the virtual energy analyzer and you can pick an address. You can pick the type of building. Let's say I want to try and I want to see a residential building. I want to see a single family home. I want to see it in Houston, Texas. You can enter the entire address if you have it, and I just run that. It will give you an archetype. So there are hundreds and thousands of archetypes in RETScreen. You can just pick whatever you want to see. So it's a predefined model with different measures implemented and the savings calculated, and they also have notes. So if you scroll down, you would maybe not this one was maybe this was not a great example for notes, but generally in archetypes they also have notes written down or measures how they've measured it. Solar water heater, solar PV, you can calculate the savings or generation out of renewables also. So you can pick any facility globally, different types, different measures implemented, and that would be a good starting point if you want to see how RETScreen is calculating these numbers or how to go about it. All right, if that's all.
Great.
Thank you so much, guys, for being patient with us. It was a long training, but thank you so much. Appreciate you all attending, and I hope you get home safely. There's a winter storm out there. For those of you online, thank you so much for attending. If you have any questions, just reach out to, again, Hardik, myself, or IGA. Happy to answer any questions that you may have.